Outside UTM.
Outside UTM. Having your breakfast?
Until now, no.
Ridwan? Khabar Ridwan?
Yes, Doctor.
You okay?
Yeah.
Alhamdulillah.
Alhamdulillah.
Rizki Zulin? Rizki Zulin, how are you?
Yes, Doctor. I'm fine, Doctor. Thank you,
Where are you
Doctor.
now?
Outside the UTM, Doctor.
You are in UTM.
Yeah.
You're
No,
going back?
outside the UTM, Doctor.
Pardon?
Outside the UTM.
Outside UTM as well.
Yes, Doctor.
Okay. Is it at home or somewhere else?
Apartment, Doctor.
Oh, in the apartment. I see. Okay. You're from Indonesia, right, Rizki?
Yes, I'm from Indonesia, Doctor. I'm from Indonesia.
Okay. So you're not going to involve in our election, eh?
Yes, Doctor.
Okay. Kahmun, how are you, Kahmun? Kahmun.
Yes, Doctor.
Are you in Kluang now?
No.
Oh, you're not going back?
I'm going Singapore now.
You're going to Singapore?
Yeah.
For what? For holiday?
Visit my auntie.
Oh, your auntie is in Singapore.
Yeah.
Are you going to overnight there?
Yes.
I see. Are you coming back for the election?
Yes.
Good. All right. By the way, when are you coming back, Kahmun?
17.
On the 17th.
Yes.
Okay. All right. We will see whether we can meet some in Kluang together with Fatima.
Oh, okay.
Discuss about the project, eh?
Okay.
Okay. Hamiza, how are you, Hamiza? Hamiza Bundo, okay? Are you okay? Dengar suara Hamiza?
Hello?
Sihat? Can hear your voice.
Hello? Is it clear?
Yeah, it's a bit, it's quite low. Where are you now? Outside from UTM?
Yeah, I'm watching.
We discussed a bit about this, okay? We said that any changes in the objective, the coefficient in the objective function, and also the right hand side of the constraint, any changes with that. So we will see what happened to the solutions or the objective, whether it's going to be changed or not. Okay, the thing is we are looking at what will happen at the optimum solution. Okay, this is the optimum solution, right? Point here, point B. If we were to maximize my exploit, sebentar. By the way, if you have any question, please voice out. Don't just let it go. If you have any question, quite blur, please ask. Right? Because we are online, so I cannot see your face. So I'm not sure whether you understand or not. Okay, if you look at this equation here, all right, remember the slope here is negative C1. This is our C1, coefficient 1, which is 50. Coefficient 2 is, 40. Coefficient 1. Coefficient 2 is 50, right? So our slope for this objective function is negative C1 minus C2. Okay, that's our slope. Okay, for this one, our slope here is the objective function minus C1 divided by C2, right? That is the slope, which is equals to, over here is minus what? 40 over 50. Okay, that is the slope for our objective function, okay, which is 4 over 5. And then the slope for your first constraint is, what's the slope? 1 over 2, right? Negative 1 over 2, y over x. Okay, and the slope for the second constraint is minus 4 over 3, which is again y over x, which is minus 3 over, sorry, minus 4 over 3. Okay, so the thing is, for the sensitivity analysis, we want to look at the first one is to look at the changes in coefficient, 40 and 50, C1 and C2, the changes in coefficient. The second one is the changes in the right hand side, 40 and 150, what will happen, right? So the changes in the objective function, the rest are whole, all the other constraints are whole, and the other coefficient also whole. So if you were to change our slope, this is the slope for the objective function, right? Okay, this is the slope, right? This is the slope for our objective function. Okay, and this is your optimum solution, right? So the thing that you can play around to look at the range between what and what. So we have this is the slope. The slope which is 40 over 50, right? So if you were to change one of it, let's say we want to change 40 to 50 or 40 to 30, right? So meaning that we are changing the slope. So the change of the slope can be upper or lower, clockwise or counterclockwise. You see, the upper part will be it change once you change the slope, right? The solution here we are looking at to what extent that the solution would change from B to A or from B to C, right? So if you move your as a B is the pivot, right? If you move clockwise, meaning you are changing the slope, upper it will go towards constraint BC, this line here, right? And then it will change to the extent that it will change your optimal solution to B. Okay, if you move counterclockwise, right? So it will, once your slope become the same as this line here, okay, then your objective function will change to, your optimal solution will change to point B, point A. So here you have two binded line here, which is the constraint 1 and constraint 2, which is line AB and also line BC, right? That is your the binded line. So if you change if your slope, objective function slope is equals to AB, then the answer will be changed to A. Or the other one is if your slope, the objective function slope is the same as line BC, which is another constraint, then you would change your result to the solution to point C instead of point B. So these are we're looking at the range. Okay, so the range of the upper and also the lower range. And if you are within that range, then the solution will remain at point B. Okay. So what we can do here is we want to find this range, right? Since your slope here, your objective slope is minus 4 over 5, right? Okay, the first one, remember the slope is minus C1 over C2. So we look at the first range here. Okay, okay, which is minus C1 over C2. Okay, if it is equals to this constraint, if it is equals to this constraint, then it will change to point C, right? So this is the maximum that will change. So meaning that if we plug in this formula here, since minus C1 over C2 is equals to this line, then C1 is equals to 66.67. Okay, do you get this or not? So this is our objective function's slope, and this is the first constraint slope. Okay, if this line here, our objective function, equals to this slope, this constraint slope, then this value C1 now is equals to 66.7. That is the upper limit of it. The other one is, okay, if our objective function is equal to this line here, right? This line here, right? Which is the slope of the objective function, negative C1 minus C, divided by C2 is equal to the second constraint here, this line, which is the slope of negative half, right? So we can find that C1 is equals to 25. So the first range of C1 that will maintain our optimum solution at point B will be between 25 and 65 for the value of coefficient of the first one, which is 40. Okay, if this 40 we change it between 25 to 66.7, so we will maintain our optimal solution at point B. Okay, now if we look at, okay, is that clear or not for the first one? The change in coefficient 1, which is 40. Is that clear? Is that clear or not? Ada jawapan pun.
Clear ke?
Clear. Okay. Or you can share at the chat whether it's clear or not. But I cannot see your face. Okay. So you have to respond. All right. The second one is coefficient at x2, which is 50. Okay, we want to change this 50, right? So what is the range of this that will maintain the optimal solution at B? So since it is at x2, so this is coefficient 2, C2. So C2 is within what? We do the same thing. Since the slope is negative C1 over, negative C1 over C2. So if we want to look at C2, so we will, the slope now is we know C1, right, which is 40. So negative 40, we know C1, which is 40, right? And we want to find C2, right? So this is the second slope here. Not the second slope, the second, I want to look at C2, what will happen, right? This one, this equation here is the slope, just like this one, right? The first one here, minus C1 over 50 is the slope, right? We want to find C1. Now, this is the same, the slope of our objective function. We want to find the C2, the range of C2, which is either it is going to be will be the same as the first constraint, or it will be the same as the slope of it, of this will be the same as second constraint. If these are the same, these are the range, the upper range and lower range. Clear or not? So this is the first one, the C1. Okay, we use this, This one is we are looking at C2 range. The slope for C, we are looking. Okay, we use this to find the range for C1, which is 25 and 66.7. Okay, this is the slope for your objective function. And we use this minus 40 divided by C2 to find the range for C2. Is that clear or not? So we have two here. One is the first, we're looking at range number 1, which is C1. And then we're looking at range number 2, which is C2. C1 over C2. Okay, this is our the slope for your objective function, which is C1 over C2. If you want to find the range for C1, right? So C1 over 50 is C2, right? So we can find the range for C1, which is between 25 and 66. Okay, the next one is we are looking at the range for C2. Then we know C1, which is 40, but we want to see the range for C2, okay, which is equal to this, between 30 and 80. So how do you get this? Again, by the be the equal of the slope, of the constraint slope. So we have done this just now, right? This is the slope here for the objective function, minus 4 over 5. The upper one, which is between, we want to look at the C1 range, right? C1 over 50 is the first one is the slope will be the same as constraint number 2, which is negative 1 over 2. So we find that C1 is 25. And then the upper one is, okay, again, this is we are looking at C1, but when the slope is the same as constraint number 1, which is minus 4 over 3, then we got C1 is 66.7. So the range is between these two. Okay, this is for C1. If you want to look at for C2, then C2 is, again, we have coefficient, we know coefficient C1, we want to find coefficient C2. The range for coefficient C2 is between, again, the slope 1, the upper one, which is here. We're looking at C2, right? So the slope between the slope 1 here, okay? So there will be the upper. So if we make it equal sign here, we find that C2 is equals to 80, right? And then the lower part, which is the slope of the objective function, should be equals to the slope of another constraint, which is minus 4 over 3, right? Then we can find the lower C2 is equals to 30. So C2 is between 30 and 80. So in order to maintain the solution, our optimum solution at point B, Okay, C1 should be between 25 and 66, coefficient 1 here. All right, and C2 should be maintained at the range of 30 to 80, which is our objective function here, the coefficient for C2. Is that clear or not? Jelas ke tidak? How to find the range for your objective function, for the coefficient, coefficient for your objective function, coefficient 1 and coefficient 2. Is that clear or not?
Yes, Doctor.
Well, look at, this is the question that I asked you, right? How do you find this range here? Okay, against C1 and C2. Okay, what is the slope for our objective function? What is the slope for our objective function?
Negative.
What's the slope for our objective function? Okay, 2 and minus 2. How do you get minus 2?
Negative 6 over 3.
That's negative 6 over 2, right? So this is our C1, this is our C2. So negative C1 over C2, which is 6 over 2. Over 3, yeah? That is the slope for the function. So in order to find the maximum and minimum, okay, the solution to this model, okay, is at point A. Okay, at point A is the solution for this, right? So we have how many binded here? The binded line. Only one, right? Only one binded line here, which is this line A, B. Okay, A is our optimum solution. Okay, the only that will bind or will change our solution from A is point B. Point C doesn't do any problem. The only thing that will happen is the change to point B. The solution can change from A to B, right? So we want to know what are the range between what? So this is our minus C1 over C2 is the slope for our objective function, right? So if it is equals to slope minus 4 over 3, which is this constraint. This is constraint what? Minus 4 over 3. Constraint 2, If the slope of the objective function equals to constraint 2, right? Then it can go to optimum solution B, point B instead of point A, right? So what is the range here? You have to, again, we want to look at C1 and C2. C1 actually is at the top here, right? If we bring this line up, okay, until the negative area, so the slope between that, so we have to again okay, the first one is this is our slope, which is equal to minus 2. Okay, the upper one, when C1 over 3, right? C1 over 3. So this is C1 over 3, right? Is equals to minus infinity, right? Because if you look at here, it can go anywhere, infinity, right? So C1 is equals to infinity, right? That is the first, which is the upper range. The lower range, the only one that can change to B is this slope, the slope of minus 4 over 3. So if our objective function slope is equals to the constraint 2, then C1 is equals to 4. So our first range is between 4 and infinity. That will change the solution to point, that will maintain the optimal solution at point A. Is this clear or not?
Doctor. Hello.
Go ahead.
I have a question. Why is the upper has infinity in your constraint? C1 equals to infinity.
Okay, again, if you look at here, right, this is our slope. Change the point. Okay, if you look at this is our slope here, right? The slope for your max. This is the line for your objective function, right? If we bring it up here, okay, the slope, if we make it equal to this line, the objective function 2, sorry, the cosine 2, then it should be equals to minus 4/3, right? But if you bring it down, we have to look at from this side, from this side. If you bring it down, meaning you bring it up here, okay? So it have no, you can go on and on without any limitation. Over here, you have limitation of this line, this constraint 2. But on the other side, okay, there is no limitation of any constraint. So if you look at up here, you bring it up, it doesn't do any. There is nothing that can stop the slope. You can change to any value. You will not change the solution of A. You will just maintain at A. That is the reason why you have infinity here. Over here, the constraint is at constraint 2. Over here, you change the other side. Okay, there is no bind. The only bind is this line. Okay, this line, there's no bind here. Nothing. Nothing can bind to point A. But for this one, this constraint, it can bind because it will change to point B. This one doesn't have no binding at all. Yang ada binding cuma constraint 2, which is slope of minus 4/3. Lain tak ada, only one. So that's why you have an infinity here. There's no binding at all. This one, the binding is constraint 2. Jelas tak? Only one binder. The line that bind to A is only one, which is 4/3, constraint 2. Yang satu lagi tak ada binder. Okay, the same with if you want to find C2. Okay, what is the slope for if you want to find C2? C2. This is you want to find C1. So C1 divided by 3, right? If you want this one to find C2, minus 6/C2, right? So minus 6/C2 if you want to find C2. Again, the upper one, only this line can bind with it, right? Only this line, which is constraint 2. So C2 is equals to 4.5. Okay, the other one, there is no bind, the same as this one, there is no bind. So if we, with this equation here, C2 is equals to 6 divided by infinity, which is 0. So the range between that will maintain the solution at point A is C2 between 0 to 4.5. Right? If C2 between 0 to 4.5, this C2 between 0 to 4.5, it will maintain the solution at point A. And if C1, this 6 here, between 4 to infinity, okay, that we will maintain to at point A. This is the range to maintain the solution at point A. Right? Is that clear? Boleh, eh?
Clear.
Right, good. Okay. We also, I'm not sure, have we discussed this or not yesterday? In last week? We discussed this a bit, right? We have, we want to find what will be the maximum profit of this situation. We have two machines, right? Machine 1 and machine 2. Okay. This is the constraint for machine 1, which is the daily availability for machine 1 is 8 hours, right? So 2x1 plus x2 should be less than or equals to 8 hours. We want to maximize, should be less than equal to 8 hours. For machine 2, x1 per hour plus product x2, sorry, x1 plus 2x2 should be less than or equals to 8, right? So if you look at this objective function, the slope for this is what? 300 divided by 200, which is minus 3 over 2. So the slope for this objective function is minus 3 over 2. The constraint here, the first constraint, the slope for the first constraint is negative 2 divided by 1, which is minus 2. And the slope for the second constraint is 1 over 2, which is, this is 1 minus 1 over 2. Okay, so the question here is what happened if we change the availability of machine 1 from 8 to 9, or we want to change the availability of machine 2 from 8 to 9. Which one will give the most impact? Is it the change of the ability of machine 1 or the change of the ability of machine 2? Okay. Means that machine, nak tengok sama ada machine 1, if we prolong the usage of machine 1 from 8 hours to 9 hours, or we prolong the usage of machine 2 from 8 hours to 9 hours, which one is more sensitive, will give more impact? Okay, we want to look at this, the change of this right hand side. Okay, which one will give more impact? Right, this is our result, and here is the optimal solution. The optimal solution here is the z value is equals to 4000 divided by 3, right, at 0.8 over 3 and 5 over 3. At this point, we will have the optimal solution, right? So if you want to change the object, the constraint, the value of the right hand side of the constraint, meaning when we want to maximize the usage of machine 1 from 8 to 9, okay, we want to see, can we increase the capacity? Which one should give we should give priority? Increase the capacity of machine 1 or machine 2? Okay, if you increase the capacity of machine 1, right? So we can, once you increase the capacity of machine 1, meaning that your z value will change, right? Now your z value from 4000 divided by 3, the new z value, okay, new objective function here will increase to 4400 and 4400 divided by 3. So we can see the increase in our to what extent it will increase. So we can look from the shadow price. From the shadow price, this is the increase, the increment, right? Which is 4400 divided by 3 minus 4000 divided by 3. So machine 1, actually we increase the capacity from 9 to 8. By increasing this capacity, the shadow price is equals to 133 ringgit per hour. Okay, the shadow price for increasing machine 1 is 1,253 per hour. Okay, is this clear? So by change 1 unit of machine 1, we increase the shadow price of $133 per hour. Okay. Now, if you were to increase, instead of machine 1 capacity, we increase machine 2 capacity. What will happen to our shadow price? Okay. by increase machine 2 from 8 to 9, it will increase the Z value, right? Our optimum profit will increase, but the increment is not much. It's 4,100. Even though we increase the same amount of the capacity of machine 1 and machine 2 to one unit, but the increment for 1 unit of machine 1 is actually increased our profit $33 per hour. So this shows that which machine is better if we were to increase machine 1 or machine 2. Machine 1 will increase $133 per hour by increment of 1 unit of capacity. Machine 2 will increase $33 per hour. Which one is better? Machine 1. Why machine 1? It is more sensitive. Okay, it looks like with this machine 1 unit change will increase $133. If we change machine 1 unit, it will increase $33 per hour, meaning that machine 1 is more sensitive as compared to machine 2. Okay, so if the question is if we can increase capacity of both, which machine should give priority? Give priority to machine 1, since it is more sensitive as compared to machine 2. So this answers the question, right? So that's the first question. The second question: should we increase the ability of machine 1 at additional cost of $50 per hour? If you want to increase from 8 to 9, you have to pay $50 per hour. So should we can we spend the money $50 per hour to increase machine 1? Is it okay? The second question.
Yeah.
Why? Why is that so? If we have to spend $50 per hour to increase the availability of machine 1, is it okay or not? I'm waiting for your answer. The first question here. What happens if we increase 1 unit of machine 1, availability of machine 1? What will be the cost, the improvement? The increase in the shadow price is $133, right? So is this good for us to spend some money, which is $50 per hour? Yes, no. Hamiza say no. Faiz say yes. If we have $50, okay, so we spend this $50 per hour for machine 1. Machine 1, if we increase 1 hour, will increase $133. So is it worth or not? It is worth, right? You spend only $50, right? But the machine increment or improvement is $133 per hour. So you have money, you have more. So $133 minus 50 is how much? So that is the amount that you will get, okay, by improving the machine 1. So it's worth, it's worth to spend some money, okay, because you will increase the capacity of that machines. Okay, so the increment will be 103 minus 50. That is the increment. Okay, what about the second one? The third one, so the third question. Should we increase the availability of machine 2 if we spend $50 per hour? Should we? Yes, loss will occur. Yeah, we are at loss. That's very good. Meaning that if we spend $50 per hour, but the machine can only increase up to $30 per hour, okay, for each unit of increment. So actually we are losing of how many? 50 minus 33, right? So it's a lose. So it's better not to spend our money to improve machine 2. But machine 1, yes, the ability not improve. So the ability of machine 1 is better because we will have more money. But then if we spend our money to improve or the ability of machine 2, it is at loss of how much? 17 ringgit, dollars. Sorry. Okay, that's clear? So this is how we can make use of our sensitivity analysis in making the decision whether to, your example here, to increase the ability of machine. Right? The next question will be, suppose that the unit profits of product 1 and 2 are changed to 350 and 250 respectively. Will the current optimum solution remain the same or not? Okay. Before this, our product 1 and product 2, the coefficient of it is 300 and 200, right? So we want to maximize the profit. So we have 300 and 200. So over here you can see that the unit profit for product 1 is 300. Unit profit of product 2 is 300. Let's say we want to change, right? The unit profit for product 1 is now 350 instead of 300. And this one we want to change to 250 per unit. You want to increase the profit. Okay. The question now is, will it change our optimum solution with this constraint? Okay, will it change our optimum solution? The current optimum solution is here, which is 4,000 divided by 3, right, at this point. But if you were to change this coefficient here, the profit for machine 1 and machine 2, okay, will it change this point here, right? So with that, we need to do some sensitivity analysis. Again, the slope is negative C1 divided by C2, right? Okay. So if you want to change this, now the slope here is minus what? What's the slope for this one now? The current slope? Minus C1 over C2 is 300 divided by 200, right? So if you were to change this, so what you can do is, you know that you will maintain this. You will maintain the solution at A is between this, right? Between constraint 1 and constraint 2. You have 2 binded here. This is your perceivable region, right? The one that will bind is constraint 1 between these two, and the other one is constraint 2 between these two. Okay, the solution will change to this point. Let me write it down here. Over here, okay, it will change to this. Or it will change to, oops. Here, right? Let's call this as this is A, this is B, this is B, this is C. Okay, the one that bind, this is point B here. Point C here. Okay, the binded line would be AB and also AC, right? So AB is the slope for constraint 1, and this is constraint 1, and AC will be the slope for constraint 2. So in order to maintain point A, it should be between slope 1 over 2, and slope 2, which is minus 2. Okay, so the range is between, this slope should be between half and also 2. Okay, now if you were to change the slope from 300 over 200 to 350 over 200, 350 over 250. So what will you get? 3 over 3.5 divided by 2.0, 2.5. So is it within this range? Can you please calculate that? Is it within that range? Question here. Is it within the range? Can you please calculate? So 350 over 250. What is the answer? What will be the answer? 1.4. 1.4. Is 1.4 within this range? Is it within this range? Yes. So should we? Will this question here? Suppose that the unit profit of product are changed to SPD. Will the current optimum solution remain the same? Will it remain the same or not? Yes, it will remain the same. So should we? It's okay, eh? It's okay if our objective now, we change the unit profit of product 1 to 350 and 250 because we will maintain the current optimum solution, which is at A. So it will not do any change of the profit is still the same. So I think we shouldn't, because we still have the same profit. Okay, if we increase our product 1 to 250, the profit of product 1 and also the profit of product 2 to 250, the optimum solution will still remain the same, right? Okay, the second question is, suppose that unit profit of product 2 is fixed at the current value is 200. What is the range of unit profit of product 1 that will keep the optimum solution unchanged? Now we changed our product 2 is to 200. We maintain 200. Yeah? Fixed at 200. Okay, we maintain fixed at 200. So C2 is now 200. We want to find C1. What is the answer here? What's the answer? We maintain C1, right? Sorry, we maintain C2. So C1 divided by, we maintain C2, 200, right? So should be equals to what? Right. So C1 will be right. Right. If we maintain C1 maintain C2 at 200. So this C1 should be 400. Suppose that unit profit of product is fixed current one. What is the range of unit profit for one that will remain with the same solution? So C1 should be 400, and the other extreme will be what? C1 divided by 200 is equal to half, right? So C1 equals to, that is the range. So the range to maintain the optimal solution should be between 100 and 200, 400. That's a new range that will maintain our optimum solution at point A, which is 4,000/3. So this is the range between C1. If you will change, if you want to change C2, C1, so we maintain C2 at 200, then the range for product 1 should be between 100 to 400. Okay. Any question? So this is how you make use of the sensitivity analysis to make some judgment whether to do some improvement or not, and also whether to change our coefficients of our objective function. Okay, so we can play around with the coefficient, and also we can play around with the the constraints, the right hand side of the constraint. Okay, that is the use of sensitivity analysis. So is it clear now? Sensitivity analysis? Jelas ke tak? Any question? Anything that's still blur? Bagilah some signal so that I know is it okay or not. Raise your hand ke, ataupun apa nama, tunjuk apa sign yang tak faham ke. Need time. Okay for now. Okay. So try to digest this sensitivity analysis. Okay, the next topic will be, by the way, have I shared the sensitivity analysis with you in the in our e-learning? Ada tak? Kita ingat. Saya share tak? Have I shared with you the slides?
Kalau yang slide tadi ada, Doktor.
Ada Okay. Good. So we are going to learn a new things, which is the integer programming. This is chapter 5. I don't think I have shared with you chapter 5. Have I or haven't? Saya share tak? Okay, saya akan share sekejap ya. Chapter 5. E-learning. I haven't shared with you yet. So chapter file, chapter 5. Okay, I'm sharing with you now. Okay, for section 7, you can get it now at in your e-learning. You get it? Chapter 5 in your e-learning. Section 7. Section 27. Right, I already shared at section 27. Okay. Okay, before this, what we learn is all about the whole number. But most of the times that we also need to, for example, a solution of 3.5 students. That is not the right solution. You don't have a 3.5 students or 255 machines, 255.5 machines. Do we have the 225.5 machines? You do 0.5 machines. You don't have 0.5%. But when you say that your solution is the average weight of the people is 65.5 kg. That is possible, right? That's a whole number. Okay. Or the weight of the rice, for example, right? The rice, the weight is 10.7 kg, or pounds. That is possible, That is a whole number. But most of the time we don't have that. Everything is in a whole number. Okay, to use for example, the average of a person is the average number of people person will be, let's say, 3.7. Can you say that the answer for this is 4 that will achieve the objective function? If the average person is 3.7, can you say that the solution or the optimum solution, the objective function is the number of person is equal to 4? The range is between 3.7. So it can be 3 or 4. But can you say 4? Saya tanya balik ni. I'm asking you, if the solution, all right, let's say we find x1, x2, x1 is the number of person. Okay, the average number of person here is, let's say, 3.7 person. Can you say that x1, 3.7 person is equals to 4, or is it equals to 3? Which one is your answer? 4. 4 or 3? Okay, we have several other constraints, not only one. One of the constraints is number of person. Okay, that is first constraint, which is to find x1, x1. But we do have another constraint, so many other constraints. So the answer of 4 is not apa nama, it's not going to be the correct answer, even though it is closer to 4, because of the other constraint that we have. So we need to check whether it is going to be 3 or 4. Okay, we are not sure, 3 or 4. Then we have to do the test, or you need to calculate the objective functions, whether 3 will achieve the maximum or 4 will achieve the maximum. Okay, but that will be under, we will discuss about this later. But meaning that integer programming is very important, very important, because not every numbers are whole number. We do have integers. Most of the time we have integers. Okay, this topic we'll talk about integer programming, and then we'll talk about the integer programming using graphical solutions. And then I hope by now you have tried your computer using solvers. Try your very best to use solver, even though we have Excel for Windows, and also we have QM. Okay, we have 2 programs, but I want you to make use of the solver. Please refer to your textbook of how to solve the problems using solver. And then today we are also going to talk about 0, 1. 0, 1 is whether it is present or not. Like for example, male and female, it's a 0, 1, right? Yes or no. Again, this is we have so many problems with respect to 0, 1 solutions. Okay, there are 3 types of model regarding the integer programming. We have a total integer model, meaning that all the solution have to be integer number. Okay, cannot have any whole number. Right. The other one is 0, 1. Again, 0 whether yes or no. Ada ke tak ada? Presence or not presence? Male or female? So there are 2 decisions here, with the 0 and 1 decision. The other one is called mixed integer. Mixed means in your solution, x1 and x2, x1 could be integer, x2 could be a whole number, right? So it can be 1 or 2 for x1. For x2, you can have 2.5 or 3.5. Okay, so you can have a decimal point. So this is called mixed integer. So we have total integer, we have a 0, 1 integer model, or we have a mixed integer model. I will just share with you a few examples here, right? To let you understand the difference of this. Okay, the total integer, meaning the answer should be, all should be an integer. We have the machine shop. You obtain 2 new press and also lathe machines, right? The profit for each press will be $100 per day, and for the lathe machine is $150 per day. With this, if you were to spend your money for this, right? Okay, then the constraint here, you have only 40,000 as your budget for both of the machines, and then the size of the floor at the factory is 200 square feet. Okay? So you have 200 square feet constraint for the space of the factory, the floor space, and also you have the constraint for the budget. Okay, again, the price, machines purchase price and the space requirement is given here. It requires 15 square feet for the press machine per machine, and for the lathe machine it required 30 square feet for each machines. And then the price for press machine is 800,000, and the price for the lathe machine is 4,000 ringgit. So what is our objective here? What's our objective? For this question, what's the objective? Minimize or maximize? And dear students, what's our objective here? Okay, you want to maximize, yes. What are you going to maximize? You want to maximize? No. But the objective. What is our objective? You want to maximize what? That is a good try. You want to maximize, but you're not going to maximize the flow. You want to maximize the price. You want to maximize the number of machines that can be buy. What is our objective function here? To maximize what? Numbers of machines? No. You want the marginal profitability is each machine. The marginal is $10 per day. The lathe is $150 per day. So what are you going to maximize? Yes, you want to maximize the profit, right? You want to maximize the profit of so that you know what's the number of the machines for lathe and press, so that you can maximize the profit, right? The objective here is to maximize the profit. Okay, how many constraints do we have here? Three constraints. Yes, we have two constraints. What is the constraint? We have two constraints. What is the constraint here? What are the constraints? Yes, the constraint of the budget, which is we have only 40,000 budget, and the other constraint is the size of the space, the size of the floor, the space, the floor space, which is 200 square feet. Okay. What will be the variables? What are the variables? What is X1 and what is X2? What are the variables? Yes, X1 is the machine press machine, and X2 is lathe machine. Bagus. Right. So if X1 is press machine and S2 is the lathe machine, so what is the equation for objective function? You can voice out, if you it's okay to chat, but if you can voice out, it's better. So Z is equals to what? You want to maximize profit.
100 X1.
Okay, 100 X1 plus
150 X2.
Okay, that's good. Okay, what about the constraint here? The first constraint.
8,000 X1 plus 4,000 X2. Less than or equal less than or equal 40,000.
Okay, that's good. Less than or equal because we want to maximize, right? Should be less than or equals to 40,000. What about the other one? The other constraint?
50x1 plus 30x2 less than or equals 200.
200. Right. The answer for x1, x2 should be integer, right? Because there's number of days and number of machines. You cannot have press as the number is 3.2 press machine. That is not possible. So because of that, you have another constraint, which is the integer constraint. So you have here not only two constraints, but you have another constraint. Okay. So you have objective function, right? This is 100x1 plus 150x2. This is the first constraint here, right? And the second constraint, but you have another constraint, which is before this, we say that x1, x2 should be greater than or equal to 0. Okay, but now you have integer. So you have to put 2 here, right? One is greater than or equals to 0, and the other one is integer. Okay. Actually, for to use simplex method is quite tedious. It's quite challenging. I'm not going to share, but I will share with you the other one is called branch and bounds. But we can use computer, right? And you have that integer as well. Right? So this is the model. You can use your software. You can click at the integer for both x1 and x2. Then you will come up with the solutions. Right? This is another problem here. Right? The recreation facilities selection is to maximize the daily usage by the resident. You want to maximize the daily usage, right? The constraint here are the budget and also the size of the space of the land. But you have another one, the selection of the constraint, the swimming pool or tennis. You can have swimming pools, or you can have tennis. You can have a tennis center. You cannot have both at the same time. You cannot have both. That is another constraint, right? So over here, it's very important for you to understand the concept of integer programming, especially with this statement here, right? You have to either having a swimming pool or tennis center. You have 4 centers. Right? You have swimming pool, you have tennis center, you have athletic field, you have gyms. Right? Your objective is to maximize the usage of the residents by the residents, the usage of all these facilities. Right? What will be your Z value? By the way, can you have 3.2 swimming pools? Cannot, right? Can you have 4.8 tennis center? Pun tak boleh. You can have 2 swimming pools, but over here is all one. 1, 1, 1. You have whether to have 1 swimming pool and athletic field and gymnasiums, or you can have 1 tennis center, 1 athletic field, and 1 gymnasiums. Okay, 1 gym. So you can have only 3 facilities at one time. Okay, we have 2 selection here, whether to have swimming pool or to have tennis center with athletic field and with gyms. In order to, the objective here is to maximize the usage by the residents. Okay, what will be the Z value here? What is our Z value here? The objective function to maximize the usage of by resident of these facilities. Mana? I'm waiting for your answer.
Z equal to 300 x1
Mhm.
plus with 90 X2 plus with 400 X3 plus 150 X4.
Yeah. Okay. There's the usage. All right. How many constraints do we have here?
Uh, 3.
Okay. What are the constraints? Good.
The $120,000 budget.
The budget. So
The 12 acres of land,
okay.
and the section constraint on whether we need to choose either swimming pool or tennis center.
Okay. But we do have another constraint, which is the number of centers. This one is whether to choose or not. There's another constraint, which is number of center. Okay. All right. For the budget, we have what? 35 X1 plus 10 X2 plus 25 X3 plus 90 X4. Should be less than or greater than?
Less equal.
Less than or equal to. And we have another one is the acres, right? 4 X1 plus 2 X2 plus 3 X3 plus 7 X3 plus 3 X4 is less than or equals to 12 acres. Okay, what about this constraint here? What will be the constraint for this? So this is X1, swimming pool is X1. X2 is tennis court. S3 will be the athletic field, and X4 will be the gym. So what is the constraint for this one? This is an OR. X1 plus X2 should be equals to what?
1.
Yes, should be equals to 1. You can only choose one. X1 plus X2 should be equals to 1. Right? And the other one, for all the constraint here, X1 plus X2 plus X3 plus X4 should be what? Should be what? Or you can have one at a time. X1 should be equals to 1, X2 should be equals to 2. Okay? 1 as well. S3 should be equals to 1, and gym S4 should be equals to 1. Okay, that also possible, right? So, not only 1, also 0, 1, because you have 2 here. So this is the objective function, right? And this is the first constraint, which is the budget, right? And the size of your field, right? Okay, this is the first constraint here. Should be equals to or less than or equal. Okay, why is less than? Less than or equals? It's not equals to 1. It's less than equal. Because can we not to choose both of this? Can we not to choose X1 and X2 with all this budget? Yes. You can not to have a swimming pool and also tennis center. That's why you have less than or equals, right? And your X1, X2, X3 is either you choose it or not to choose it. If it is equal to 0, meaning you are not choosing it. It's equals to 1, then you will choose it, right? So this is the constraint of whether to have or not to have. Okay, so the answer could be any 3 of the facilities, not 4, or you can have only 2 facilities. Okay, because of the budget and because of the size. Only 2 facilities, could be swimming pool and the gym, or the tennis center and the athletic field. Depends, right? Or you can have 3, but you cannot have 4 definitely. So this is the equation, and you can see here the usage of integer programming, 0, 1, and 1 here. Because of that. Okay, you can try your just plug in all these data in your solvers, and please make use of this. Use these problems and use your solver. Make sure you know how to use it. Okay. This is the third example. This is about investment. You have $250,000 investment that will give the highest return after 1 year. Okay, you want to invest by having a condominium, which cost of 50,000. This is US dollar, right? 50,000 US dollar per unit. And after that, if you buy this condominium at 50,000, after 1 year, you will sell it with a profit of 9,000. Okay, you can make a profit from this investment by selling it after 1 year, and the profit is 9,000. Or you can buy a land with the price of 12,000 per acre. After 1 year, you can sell it. You can make profit from this by $1,500 profit after 1 year. Or you can invest on buying bond, the share, right? By buying the bond or the share, the price for this is 8,000, and you can make profit by selling it after 1 year with a profit of 1,000. Okay. Over here, you have only 4 condominiums, right? Investment of only 4 condominiums, the maximum condominium that you can invest. Or you can have 15 acres of land. Again, this is the constraint for the land. Or the bond, you can have a maximum of 20 shares that is available of bond. Okay, so here, what will be your, why this is called integer programming? Why this is called integer? You can have only 4 condominiums, right? Can we have 3.5 condominiums? Can we own 3.5 condominiums? Can or not?
No.
No, right? So this is integer. What about land? Can we have 9.5 acres of land?
Can.
Can. Okay, that's the reason we call it mix. Mix because we have one solution x1, which is integer, but x2 is not integer. Okay, it's a whole number. What about the bond? Can you have 3.5 bonds? Can we buy 3.5 bonds?
No, I think.
Can you have 3.5 bonds? The municipal bond, the share.
No.
Right. You can buy only 1, 2, 3, 4. So this is again integer. So you have 2 integers here, which is condominium and bond, and you have one whole, which is the land. Okay. So what will be your objective function here? Is the profit, right? So maximize the profit, 9,000 x1 plus 1,500 x2 plus 1,000 x3. And you want to maximize the profit. Okay. What will be your constraint? By the way, okay, the profit. What will be your constraint?
There is 4 constraints. The number 1 is the total budget, $250,000 available for the investments. The number 2 is only 4 condominium can be bought. The number 3 is 15 acres of land. Number 4 is only 20 municipal bond available.
Okay. All right, good. And also the other constraint, this is the main constraint here. The other constraint is the whole number and also the integer number. Okay, for the respective selection. So what are the variables here? What are the variables?
X1 is the condominium.
Mm-hmm.
X2 is acres of land. X3 is municipal bond.
That's very good, eh? Okay, now you have this will be your variables, right? You want to maximize your profit, right? And this will be the first constraint is your budget, right? So the condominium should be less than or equals to 4. You can buy 3, 2, whatever, but it should be less than or equals to 4. The acres, okay, X2 should be less than or equals to 15. The bond, okay, X2, why X2 is less than or equal to 0? What is X2? X2 is your acres, right? This means that this is not non-negativity. Okay, this is the only one that is not integer. Okay, you can have more than or equals to 0. But for X1, the condominium and bond, this is, you have two here. One is the non-negativity, and you have also integer. This is common one, eh? Non-negativity. But over here, you have non-negativity, and also you have to make sure that both 1 and 3 have to be integer. Okay, so you need to again use the software. You have to define as X2 as whole number, and you have to define that X1 and X3 is integer. Okay, and then you solve the problem. Any question about this? Why don't you use equal signs here? X1 is equals to 4. What will happen if you put equal signs? If you put equal sign, what will happen instead of less than or equal?
It means that the value are fixed.
Very good. Meaning that you have to buy 4 condominiums. Definitely you have to have 4 condominiums if you put it equals to 4. But that is not the question here, eh? The question here, how many condominiums, how many acres of land, how many bonds you want to buy, so that you can have the maximum profit. You can make the most that you can, right? All right. Again, I asked this question earlier. Rounding the non-integer solution value up to the nearest solution value can result in. There's a problem. Eh? Sometimes if we round it up, okay, it might goes to the infeasible region. Okay, remember the region. Okay, you have to make sure that your solution have to be within the infeasible area. That is one of the reasons why you cannot round up or round down. Okay. The feasible solution is ensured by rounding down non-integer value, but it may result in less optimum. If you round it down, right, the result will be less as compared to if you round it up. So because of that, you need to do some, we call it this branch and bounce. Okay, to find what will be the best. You cannot do round up or round down. Okay, for the values. If you round up, it can goes to infeasible solution. If you round down, it might goes to the not optimum solutions. Okay. So what you have to do here for integer, right? Let's say B is your solutions, the optimum, but then B is not integer for some, for example, this question here, all right? The number of leaves. You cannot have 2.22 press. Okay, no way, eh? You're gonna have 2.2 price, number of price, or X2 number of leaf to 5.55. So because of that, if you look at the within this feasible area, your solution could be 1/6, meaning that X1 is equals to 1 machine press, 1 machine press, and 6 machine lathe. That will give the maximum profit. Or you can have here, which is this is also the closest to B, the closest to point B would be this one, x1 and x6, x2 would be 6, x1, or you can have it here, which is x2 is x1 equals to 2, and x2 is equals to 5. If this is the one, okay, if this is your point that you take, then your z value is 1000. But if you have here, the z value is 950. Okay, but you cannot have it here. You cannot put like 2. B1 is equals to 2, or the closest one is what? 28, because this is away from your visible area. Or you cannot have 3 x1 and 6 x2, because this is away from your visible region. So your answer should be within this region. So you need to check whether to have it as 1, 6 or 2, 5. Okay. Any question? Is that clear about the way of getting to your solutions for integer programming? Okay, you can do it graphically, and then you can make the choice, right? But you also can use mathematical equation. Okay, you can run it in software. Okay, but you have to remember this is integer. Okay, the traditional effort to solve integer programming problem, you can use feasible solution. You can do some sort of partitioning, as we have done just now, into smaller subset, and then we use the correct one. Okay, smaller subset evaluation until you evaluate this small subset until you find the best solution. The method is quite tedious, especially when you have a complex mathematical process. Over here is easier because we have only 2 x1 and x2. But what if you have more? Then it becomes more complex. Okay. So you might want to use this, the software. And then the other method is important, called branch and bounds. If we have time, we will cover this, or we don't have time. So next meeting tomorrow, we will cover this branch and bounds. Okay. This is another problem. Okay, you should use the computer simulation. Example here, we have 3000. The previous one, the vacation facilities, whether to have that or not, whether to have the facility or not. And okay, we can actually use this is using Excel for Windows. Okay, you put all the value here. These are the objective function to have as many exposure as possible. And these are the constraints, right? So you have the constraints, which is the first one is the budget. The second one is the size, right? And the third one is the contingencies. This is actually, if you run it, make sure you have to know how to list this, and then you can solve the problem by having all this data into this. Okay, but then you need to do some things, which is whether it's integer or not. This is complex, and then some the restriction that you have to put, whether it is integer or not integer. And this is a way of doing this, to make it integer and also 0, 1, 0, 1 value. Okay, so maximum, minimum, and then you have to set whether it's object, whether it is integer or not. Okay, so make sure you try this one using your computer. All right, these are the things you have to do. Change the bin you have into 0 and 1, and also you have to deactivate the ignore integer constraint. Okay, and then you press the OK function. All right. Another problem, which is this machine shop, right? Of the same one. You want to maximize the profit. These are the machine shop. The constraint. You can use the again model here using Excel. So the type here, x1 is 0, 1, okay, and x2 also 0, 1, meaning yes or no, and then x4 is an integer, right? Whether to have or not to have. So the final, if you run it, the final solution for this problem, if you run this model in Excel, x1 is equals to 1, meaning you have you need to have swimming pool. You don't have tennis, you have athletic field, and you don't have gymnasium. Okay, with this solution, you will have the highest or the maximum exposure or usage of the people of this recreation center. So the solution for this is having one swimming pool and one athletic field will expose will make the highest usage of the facilities. So please again run this in your software. Yeah, solver, use solver. Okay. So this is another problem, right? Using solver as well. And the solution to this, make sure you have the solution. And the last one here is whether to buy condominium or land and all that. And these are the solutions. Okay, for this, make sure again you use the solver and make sure you know how to use this. Okay, this is another example which is we haven't discussed. Okay, we will discuss this a bit in next meeting, and also the branch and bounds. I think that's all for today. You have any question? Can you please on your camera?
Doctor, my camera is not working on my PC.
Okay, thank you.
Just notify, sir.
Please, can you please on your camera? The one that is you can on your camera, please. Okay, by the way, this is your again. I'm going to share your attendance. Oops.